Today we're going to go over modeling fluid flow and thermal as well in Solidworks. Step one is to bring in the Solidworks flow simulation and Solidworks simulation. As you can see, we've actually started from having a solid part already. So select the flow wizard. We'll be setting up the fluid flow condition. At this point, the wizard pop-up comes, and the wizard pop-up appears. Go ahead and rename the study to something you can remember later. You can also pick the unit system if you're using SI or English Standard. We're doing internal flow with heat conduction through the solid material walls. You can pick other conditions. At this point, you select your working fluid. We used air. This is to simulate a exhaust manifold. Even if you selected a material for your actual model, at this point you will have to reselect the model material again, and you can use it in the model drop-down. The wall conditions will have to be convection, and you will have to have a somewhat accurate coefficient of convection that you added at that point. The initial outer conditions, that's the ambient temperature, pressure. Also any airflow, like wind speed, if there is. Go ahead and accept the default mesh size. If you want better results, you can tune down mesh results, but it will take longer. As you can see in the model, it's not actually open. We made caps, and that is because of the heat transfer analysis that we're doing on this. They have to be set as insulators. So you select each cap and select the solid insulator material. Now you'll set up the boundary conditions for the inlets and outlets. For this, you must, I repeat, must select the inside face. If you select the outside face of the caps, then it will confuse Solidworks, and it will think you're trying to do external flow. The inlets will be set to temperatures and pressures, and the exit cap should be set to ambient or external conditions. For this, that exhaust manifold will be up against a very hot engine, and so we set up a temperature boundary condition where the manifold connects to the engine. This is where you actually select which global goals you want the software to solve for. For our case, since we're doing a thermal check afterwards, after this fluid flow, we have to have velocity, heat flux, and the solid temperature. Thermal analysis later on will not work without all of those. So now we can run the simulation. For this simulation, it should be noted that you really should have no other simulations open at all. We tried it a few times, and it does not work. Also, this will not be renamed. It ends up getting numbered only, and so try to keep track, or maybe set up a new folder. What we did is actually saved it to the desktop. It will run the simulation, but it basically shows that there's no results, so we have to right click and insert the surface plot. And so select whatever actual parameters you want plotted, and then select all the surfaces you want it plotted on. That's the results of the thermal effects of just the fluid flow through our solid. You can also add the fluid flow trajectory. Again, when selecting the inlet and outlets, make sure it's the inner surfaces of those caps. If not, then it'll again confuse Solidworks, and it will not show a fluid flow. And then if you select on a wireframe, you can actually see how the fluid flows through there. This is very important here. You have to export the results to simulation, or else this will have no effect at all on a thermal simulation later on. At this point, though, we can switch to SolidWorks simulation and select a new thermal study. Actually, select new study and then click on thermal. You have to actually go down after you select the new study to hit study properties, and that's how we'll import the flow information. The box that you can see checked now, that's include fluid convection effects from SolidWorks flow simulation. At this point, that's when you really have to remember exactly what file it is numbered as, because as said before, you cannot rename these while doing the simulations. This is another important part. After you're in here, if you do not create this mesh, then it will try to run and it will fail. It will actually give you a warning saying to create a curvature-based mesh, and then if you, after that, go and create a curvature-based mesh, your simulation will not run. We tried it and we had to close everything out and restart it. So that's the results right there. All those little arrows on the model in the bottom right there, that's the convection from the thermal flow, the thermal study, excuse me. You can also do stress analysis, other things. Our pro tips, like as I said before, close all the studies beforehand. The outer edge of the cache will confuse the program, and the curvature-based mesh is required. Thank you, and I hope you all the luck with your thermal study.